Hey students, this is lesson 6.2. We're going to learn how to solve systems of equations using substitution. On the last lesson, we learned how to solve systems using a graph, and now we're going to find a new method for solving systems. So go ahead and do this review. Check back with your answers. All right, substitution, the premise behind substitution is that we can replace any value with an equal value. And just to give you a quick example of this, let's say we have 3 plus 5 plus a is some expression I have to figure out, but I know that a is equal to 10. Then I can just put 10 there and simplify this expression and figure out that the value of that expression is 18. So we're going to use that idea. So in this first equation here, I have y is equal to 5x. In the second equation, I have x plus y is equal to 12. So basically what we're saying here is that one of these numbers is 5 times as big as the other number, and these two numbers add up to 12. So if we want to solve that, what we can do is just anywhere in one of the equations that I have a y, I can replace with a 5x, since y is equal to 5x. So instead of writing x plus y is equal to 12, I can write x plus 5x is equal to 12. And notice I substituted 5x for y, and the reason I did that is because y is equal to 5x. They have the same value. And the purpose of substituting is now I have an equation with just x's in it, and I can solve that. I can simplify x plus 5x is equal to 6x, and now we can see that x is equal to 2. And once I know that, I also know that y is equal to 5 times x. So, and I found out x is 2, so I can substitute 2 now there for x. And I know that y is equal to 5 times 2, so y is equal to 10. And now it all kind of makes sense because we can see that y is 10 is 5 times as big as 2, and 2 plus 10 is equal to 2. All right, go ahead, you try it. Substitution here. Check back for your answer. Let me go through the first part with you. Notice in this system of equations, y is equal to two different things. It's equal to 2x plus 7, and it's equal to x minus 1. Well, since both of those are equal to y, that means this and this must have the same value, because they both equal y. So we're going to use the transitive property to create one equation out of both of those, just saying 2x plus 7 is equal to x minus 1. So that's this equation. So now, since there's only one variable in this equation, I can find the value of x, subtract x from both sides, and we get x plus 7 is equal to negative 1. And then subtract 7 from both sides, and we get x is equal to negative 8. And we also know, and I can use either equation to figure this out, but I'm just going to use this equation. We know that y is equal to x minus 1, or y is equal to 1 less than x. And we know that x is equal to negative 8 from the last equation, so I'll substitute negative 8 for x. And I get y is equal to negative 9. Now, just to make sure that all that works, we are going to substitute the solution, which is negative 8, negative 9, into both these equations and make sure they're true. And in both cases, we end up with true equations. So our solution works. All right, what is the solution to this system? Use substitution. In order to use substitution, we have to have a value of a variable that we can substitute into the other equation. So we either have to know what x is equal to or what y is equal to. We really don't have that in either of these equations. But notice in this equation that x is alone all by itself. So it's pretty easy to solve for x in that equation. Transform that equation by isolating the variable x. To do that, we just have to add 2y to both sides. So we get x is equal to negative 6 plus 2y. Now, x and negative 6 plus 2y have the same value. So I'm going to take my other equation, 7x minus 3y equals 2. And where I have x, I'm going to substitute negative 6 plus 2y. So instead of 7 times x, I'm going to do 7 times negative 6 plus 2y. And other than that, the rest of the equation is the same. I'm going to use the distributive property here. I'll simplify. I'll add 42 to both sides. And divide by 11. And I get y is equal to 4. Now, since y is equal to 4, we can figure out what x is equal to. Right back here, we know x is equal to negative 6 plus 2 times y. And I now know that y is equal to 4, so I'm just going to substitute 4 in for y, right there. And I get x is equal to negative 6 plus 8, which is 2. So my solution is x is 2, y is 4. Now, to check that solution, we want to make sure it works in our equations. I'm just going to do one of the equations, but you can get the idea here. So 7 times x minus 3 times y has to equal 2. That's my first equation. So that means 7 times 2 minus 3 times 4 has to equal 2. Which means 14 minus 12 has to equal 2. And that's true. The other check, you would take negative 2y plus x has to equal negative 6. Then you would substitute 4 for y, substitute 2 for x, and make sure that's equal to negative 6. And that's negative 8 plus 2 is negative 6, so that's also true. All right, go ahead and try it. On this problem, check back with the solution. All right, here's your work for that one. Problem 3, using systems of equations to solve a problem. All right. The school bookstore sells t-shirts for $8, sweatshirts for $12. Last month, the bookstore sold 37 t-shirts and sweatshirts for a total of $376. How many t-shirts were sold? Now you could guess and check and find the answers, but algebra makes this a lot easier. Let's just let x equal the number of t-shirts sold, and we'll let y equal the number of sweatshirts sold. And thinking about that, we know that if we add the number of t-shirts, x, plus the number of sweatshirts, y, we will get 37 t-shirts sold. We also know that if we add up $8 for every t-shirt sold, plus $12 for every sweatshirt sold, we will get the total amount of money raised by selling t-shirts and sweatshirts, which is $376. So now we have two equations with two unknowns, and we can use substitution to help us solve this. I'm just going to change this first equation. Since I want to know how many t-shirts were sold, I'm going to solve this equation for y, which isn't too hard. All I have to do is subtract x from both sides. And so y is equal to 37 minus x. That kind of makes sense. What I'm saying is the number of sweatshirts is 37 minus the number of t-shirts sold. Now I have a value for y of 37 minus x. And in this second equation, I can substitute that 37 minus x for y and create an equation with just one variable, which I can solve. I can just use a distributive property, and 12 times 37 is 444, minus 12x is equal to 276. I can simplify that, and I get 444 minus 4x is equal to 376. All I did was combine like terms there. 8x minus 12x is negative 4x. And subtract 444 from both sides, and I get negative 68. Divide both sides by 4, and I get x is equal to 17. So 17 t-shirts were sold. Now to check that answer, you could find out how many sweatshirts were sold, which is 37 minus 17, or 20 of them, and do 20 times 12, which is 240, and then do 17 times 8, which is 136, and then add those $2 amounts together and make sure you get 376, which you do. All right, go ahead and try problem 3 and check back on the solution. All right, sometimes when you have a system of equations, the results may turn out a little bit weird. Remember that if you get a true statement when you're solving something, that it's an identity and there's infinite solutions. If you get a false statement, such as 8 equals 2, then the system has no solution. So if we use substitution here, we get 6y is plus 6y plus 2 times, instead of x, I'm going to substitute what x is equal to, which is 3y plus 4. And that's equal to 8. Then I'm going to simplify this. 6y plus negative 6y plus 8 is equal to 8. And 6y plus negative 6y, well, that's 0 plus 8, which equals 8, and that is true. So this will have an infinite number of solutions. It's an identity. Now, the second equation, in the first equation, y is equal to 4x minus 9. So I'm going to put 4x minus 9, where the y is right here. Subtract 4x, and that's equal to 6. And now I'm going to just simplify this. 4x minus 4x is 0. So I have 0 minus 9 is equal to 6, which means negative 9 is equal to 6. That's false. So this is an example of no solution. Right? Here's your answers to problem 4. I'm going to pause. And here's the lesson check. This, if we solve the first equation for y, right here, then we only have to do one operation to get that.